go ahead and move on to the third row elements and figure out their electron arrangement. It is a little bit more complicated with third row elements. And also I'm going to talk a little bit about figuring out how you would also decide how many electrons an atom needed to either gain or lose in order to be stable. Okay, let's go ahead and pick phosphorus. Phosphorus is a fun element to work with. So phosphorus has an atomic number of 15, so therefore it has 15 electrons. Let's figure out how those 15 electrons fill into an atom. Okay, so now here is my simplified picture of an atom. But now the atom is larger. It has a larger radius, and that is because we have to add a third shell of electrons surrounding our nucleus. Okay, phosphorus had those 15 electrons. Let's go ahead and fill in the number of electrons. Okay, electron number 1 goes into the s orbital in the first shell. Electron 2 into the s orbital in the first shell. Electron 3 into the s orbital of the second shell. Electron 4 into this s orbital. Electron 5 into this p orbital. Electron 6 into this p orbital. Electron 7 goes here. Electron 8 would go here. Electron 9 would go here. Electron 10 would go here, and now we have filled our second shell. Let's go ahead and move forward with those last 5 electrons. Okay, this is going to get a little bit more complicated. Electron 11, you probably guessed, goes into an s orbital. Electron 12 also goes into an s orbital. So now where does electron 13 go? We have the option of p orbitals and d orbitals. If you have been able to read and understand your book very well, you should know that p orbitals are lower in energy than d orbitals. And so electron 13 will go into a p orbital. Electron 14 will go into a p orbital, and electron 15 will go into a p orbital. Okay, so that's how we fill electrons into an atom if we're dealing with third row elements. But now let's talk about a couple of complicated issues. Well, the first one maybe is not so complicated. And the question is, how many valence electrons does phosphorus have? Well, again, to figure out the number of valence electrons, you count how many electrons are in the outermost shell. And I count that I have 1, 2, 3, 4, and 5 valence electrons. So now the question is, how many electrons does phosphorus need to either gain or lose in order to reach a stable configuration? What you notice from this complicated picture is that there are a lot more spaces to fill in electrons. We have 3 p orbital spaces that need to be filled, and we have 2, 4, 6, 8, and 10 d orbital spaces that need to be filled. In order for an atom to reach that Nobel gas configuration, we need to completely fill the highest energy orbitals that have only been partially filled. That means for phosphorus, we would want to gain 3 electrons. We would fill the p orbitals. The d orbitals would be completely empty. However, they are high in energy and our atom would still be stable with 3 electrons.